Hello guys, this is CodeNCode and this is video editorial for the problem trapping raining waters taken from Leetcode, and the difficulty of the problem is stated hard on the website, and this problem have been asked in interviews of Amazon and Microsoft. So let's see what the problem statement is. You are given an integer. Basically you are given n bars, okay, and height of bars is given as integer input. For example, the first bar is of length 1, second bar is of length 0, and so on, okay. And you have to tell what is the total amount of water that you can trap, that can be trapped inside this structure, or the maximum amount of water that can be trapped, right? So this is 1 unit of water. Here we are able to trap 4 units of water. Here we are able to trap 1 unit of water. So in total 6 units of water you are able to trap. So this is the problem statement. You are given input, integer input, which describe the height of the bar, and you have to find out the what is the maximum amount of water you can trap inside these bars. This is the problem statement. So now if you are preparing for interviews, some of the suggestions that some of the guys have given in their interview experience is that, first of all, when you are asked to solve certain problem, don't focus to providing just focus on providing a functional solution, even if it's brute force, okay? Don't just go ahead and think, okay, I'll go ahead and optimize the solution right away. No, don't do that. Just go ahead and write a functional solution, and then if the time permits, which will most likely, if you have provided the brute force solution, that then tell the interviewer that, okay, this is the way we can optimize, be time or memory. This is the way we can optimize, and then tell them the optimized solution. This is a better way to do. So okay, and if you are not able to reach to conclusion and you are not able to find out the solution yourself, don't shy away. Interviewers usually help in, and they provide usually hints. So don't just shy away and ask them if they can provide any hint, and usually they provide. So keep these things in mind, okay? So let's see how we'll solve this problem. First of the hint that I would like you to give, just think in terms of how much water each bar can save at max, okay? So just think about this hint and try to find the solution of this problem, okay? Now, before we continue, for all of those who want to become a software developer or just have become software developer, Unacademy brings you a platform where you can get access to weekly shows which you can watch live. Some of the shows which are going to be live soon on Unacademy are hiring updates in startups and major tech companies, eligibility criteria and how to apply for them, live mock interview sessions, and pre-placement talks where HR from top companies come and talk about their hiring process. Top 20 questions which are asked in interview and how to solve them. Weekly projects which would make your resume stand out in the crowd, right? Life journey of fellow coders working in FAANG companies, and many more shows like that. You will also have an option to interact with industry leader on the platform and get a chance to take part in the online mock interviews to sharpen your skill and get a real-time feedback. You get all of this and much more with a nominal fees of $9.99 for entire year. If you use my code, you can get the same for $8.99. This is a must-have subscription for people who want a career as a software developer. Here you can see in this course, Yogendra will be solving CodeChef problems, and he will be discussing how to approach a particular problem, what technique you should follow so that you don't get TLE. And for each problem, he will be discussing the time and space complexity as well. You can find all of the relevant links in the description of the video and also my code. So let's get back to our lecture. So now we have seen what is the hint. So the question, the hint was how much water can a particular bar at max save. So the question is, how much water does this fifth bar can store at max? We can see it can store 2, right? 2 units of water. How? See, for that, what you can do, you can calculate using this formula: minimum of maximum height on left, maximum height on right. I'm talking about the ith, for the ith bar. For example, for here we are talking about the fifth bar, okay, minus height of the bar itself, right? So maximum on left is 2, maximum on right is 3, minimum of these two is 2 itself. So 2 minus 0, which is height of the bar, is 2. So this is able to store 2 units of water. The question is why does this formula work? So first of all, think about it. See, what is the maximum on the left and the maximum on right? These actually define the limit of how much water they can trap inside them, right? For example, here this is having height 3. So basically it says, okay, I can store water up to level 3. It says, okay, I can store water up to level 2. Clearly this is able to store water up to level 3, but if we go beyond 2, right, this will simply not be able to stop them, and the water will overflow and will get out of this place. So clearly maximum height determines what the water what is the level of water they can actually trap. So for each bar, you have to calculate what is the maximum height on the left and what is the maximum height on the right. Once you have these two, for example 3 and 2, what is the minimum of them, because that is the amount of water it can trap, minus height of your own, I mean height of the ith bar, and that way you will be able to calculate what is the amount of water the ith bar can store. So ith bar, fifth bar can store 2, fourth bar can store 1, sixth bar can store 1, and this will be able to store 1, and this will be able to store 1. So for each bar we will calculate how much water they will be able to calculate, I mean save, and then the sum of overall will be your solution, right? So what you need for each bar, you need what is the maximum height on the left and what is the maximum height on the right. So here L and R will tell you exactly that. See, we will be solving using prefix max and prefix max, and from left to right, and of course prefix max from right to left as well. The same problem can be solved using 2 pointer as well, and that will optimize memory, because here you need big O of n extra space, right? If you use 2 pointer, you actually don't need these two array. For now we need this array. The approach that I am discussing will use these two array, but you can solve the same problem using 2 pointers, and that would not require extra memory. So first let's discuss this. So for each rod of bar, we are storing what is the maximum on its left. For node 1 and the last node, for node 1 on the left there is nothing, right? So you can say maximum on left is 0. For node, last node, right, on the right it has nothing, right? So you can say what is the maximum on the right of the last node, that is 0. Okay, so L will store for each node I, for I don't know why I always call them node, for each bar I it will store what is the maximum height of the bar on the left of it. For example, node for bar 4, if you see all of the bars which are on left of it, maximum height is 2, so that's why we have here 2. You can prepare this array from left to right and this array from right to left in big O of n time. If I show you the code here, you see, okay, L and R, two arrays, L of 0 and R of n minus 1 is equals to 0. Okay, this is the maximum value. I'm preparing left array from left to right, from 1 to n minus 1. Okay, I'm preparing right array from n minus 2 to 0. Basically I'm preparing right array from here to here, from right to left. Okay, so here you see maximum value, maximum val will store maximum value found till I minus 1. Okay, so what is the maximum height on the left of I will clearly be the maximum height till I minus 1, and that is exactly stored here. And after that update maxval, that will be equal to maximum. If the ith height of the ith bar is actually greater than the maxval, current maxval, then we are updating here. So preparing the prefix max array from left to right for L, preparing the prefix maximum array from right to left using R. Actually we are starting from n minus 2, because n minus 1, R of n minus 1 we have already defined. Okay, after running through these two, you will have L and R. So if you want to know for the ith bar what is the maximum height on the left of it, you can go to L of I. What is the maximum height on the right of it, you can go to R of I and take minimum of that and subtract the height of the bar itself. Okay, so here you see for each bar from 0 to n minus 1, we are calculating what is the minimum of L of I and R of I and subtracting the height of the ith bar itself. What is this max of 0 comma this? See, the answer can be 0 itself. I mean sometimes they won't be able to store anything and the answer can be negative. In that case we have to ignore that. For example, this, what is the maximum on left? It is 2. What is the maximum on right? It is 2. So minimum of 2, right? 2 minus height of the bar, which is 3. So 2 minus 3 is minus 1. You should not add minus 1 to the result, right? If it is 0 or less than 0, we have to ignore it. And that's why if this becomes 0, then if this becomes 0 or negative, we will simply take 0, right? In that case, this is basically ignoring the negative cases, right? You can either write if else case or you can go with this approach. So after that, simply return the overall result, and that way you will be able to solve this problem. Okay, so yeah, this was all. This was the solution of this problem. If you have any other problem asked in any interview which you think is actually hard and you require solution of that and explanation, you can post it down in the comment section. So this was all for this lecture. Thank you guys for watching, and till the next video drops, keep coding. Thank you.